In this problem, we want to find the two values between which the middle 64% of values lie if the mean is 77 and the standard deviation is 10. So let's draw our normal distribution. Let's see exactly what we're looking at here. Okay, so the mean is 77, standard deviation is 10, and I really don't have to go into this much detail when I'm working the problem, but I just want to be clear what's going on. So I'm marking off my standard deviations. Okay, so we want to know between which two values the middle 64% of values lie. And I'd have to estimate at this point the 64%. I don't know precisely, but let's see. We do know that 68% fall between 67 and 87, roughly, based on the empirical rule. So I'm going to say that 64% falls roughly here. And again, I really don't need that knowledge. I don't need to be that precise about exactly where is the middle 64%. I just want to mark 64% under my normal distribution, and then I look to see, well, then what percentage is in the tails? So the tail areas, here's the left-hand tail, and this extends all the way out to negative infinity. And then here's the right-hand tail. This extends all the way to positive infinity. So to find the percentage that falls in the left tail and the percentage in the right tail, what I'm going to do is I'm going to take 100% minus 64%, and that gives me 36%. And that's the total of the two tails. Since there's two tails that have half of the values each, we divide that 36% in half, and I've got 18% for each tail. Oops. Okay, so now if 18% is in each tail, what I'm concerned with, and I'm going to erase some of the stuff that I've done here. I'm going to take out these bottom values. I'm not really too worried about what those are. Take that out. Okay. So first of all, I want to know what this value is. That's my left-hand boundary. And then we'll find the right-hand boundary. So to find the left-hand boundary, I say what percentage of values fall below that boundary point? 18%. That's pretty easy to read right off the graph. So because we know a percentage, we know an area, and we want to find a boundary value, we're going to use the inverse norm function in the calculator. And we get to this the same way we do the normal CDF and also the binom PDF and binom CDF that you saw in Chapter 6. So you press second inverse, just as a reminder to get there. So second inverse to get to inverse norm, and then I say what percentage falls below or to the left, and that's 18%. So I change that to 0.18 because we have to give that as a decimal. And then I give the mean and standard deviation. And that gives us the precise value on the number line. And when I do that, let's see what I get. And that is, let's just round it to the nearest tenth, and I'll say 67.8, which was very close to what I had before, right? I think I said that this was 67, right? This is 77 in the center. This would be 67, and this is just a scooch up from there. Okay, so that's 67.8. Now I want to find the second boundary value. And so what I'll do with this, again, I'm going to use the inverse norm function. And now I can do, oops, let me draw that a little bit better. 1 minus 18%, comma 77, comma 10. Now this is one way to approach this. Why did I do 1 minus 0.18? Here I have 18% in the top, 18% going to the right. That doesn't work for finding this value because this value, to find this value, we need to know what percentage falls to the left. So what falls to the left, it's 1 minus the 18% in the upper tail by using the complement. Or, another way of going about this, I want to know what percentage falls to the left here. I could take 18% plus 64% and get 82%. And that's the same thing as if I do 1 minus 0.18. So either way, it's 0.82. Notice that if I type this into the calculator, I'm not even finding the 0.82. That's not really necessary. The calculator will do that subtraction for you. And when we do that, we get 86.2. And that's rounded to the nearest tenth of a decimal place. So that's how you would find the boundary values there. So for my final answer, what we see is that we have, this was 67.8, and this is 86.2, and those are our left and right boundary values. And that's how you do that problem.